Okay, so we did about two graphs yesterday, and today we are moving towards furthermore things about that. Okay, and let me draw the graph first. Okay, I'm just changing it into the graph form, so it will be helpful for us. I think it's going to be. Let's draw the graph. We have the graph like this in yesterday's class. This is the most common graph of this chapter that I'm going to show you over here. This one. For example, the graph is going to be move like this. This is the very common graph of this chapter. Okay, so everyone, you need to see this graph. That what is the graph telling us? The graph is telling us what? For example, we know that over here we have time, right? This is time. This time may be in minutes, in maybe in seconds. It is all about the exam question in which they are asking or they are giving us. Okay, and over here they are giving us the volume of gas. Okay, like this. This is the volume of gas, because I have told you in the previous class that on y-axis we are going to use volume. Okay, for example, whatever the gas, let's suppose it is the volume of carbon dioxide gas. Okay, and it is what? The time in minutes. Okay, let's suppose it is in centimeter cube. Okay, so it is 10 centimeter cube, 20, 30, 40, 50, 60, 70, 80, 90, and 100, right? So this is the graph. So how can we use this graph to find out different things, right? The first thing that you need to understand, we are going to use this graph to find out many things, right? Number one, we can use this graph to find out the rate in the first minute, then the rate in second minute, then the rate in third minute, and then the rate in fourth minute, right? You can see that after 4 minutes the reaction is completed, because this is the reaction has been completed because the graph is constant, right? Straight. So we can use this in this way. For example, if you want to find out the rate of first minute, so it is what it is nearly more than 25 now. So whatever the, for example, if it is in exam, so definitely we have 10 more small scales over there, so you can easily find out what is this. So right now it is 26, right? So 26 centimeter cube gas in the first minute. So it is what? It is the rate, 26 centimeter cube per minute. Okay, and in the second one you can see this. The second one is just like you can see that it is 26 and it is almost 47 somewhere. So we can use this 47 minus 26, 47 minus 26, and the minute is also 1. You can see this. This is the second minute. So it is, I think, 21 centimeter cube per minute, right? And then in third minute, you can see that it is 59 somewhere. So 59 minus 47, it will give us what? It will give us 12 centimeter cube per minute, right? And then it is 70. So it is 70 minus 59 over 1. It is 11 centimeter cube per minute, right? So you can see over there, the first thing that I told you in the previous class as well, the rate is decreasing, right? The first thing that we know this, the rate of reaction decreasing. The rate of reaction decreases, right, Bacho? The first thing
Yes.
that we just got it. And the second thing that we got it is the maximum volume of gas that is produced is in this reaction is 70 centimeter cube of carbon dioxide produced, right? This is the maximum volume that is produced. And after that, the reaction has been completed, right? And the third thing that we just got it from this is the reaction has been completed in 4 minutes. Reaction completed in 4 minutes. Reaction has been completed in 4 minutes, right? So these are the three different conclusions of this graph, which is very important, right? This conclusion is very important, so you need to understand this, and it will help you to find many things over here, right? So examiner can ask, calculate the time in which the reaction has been completed. So it is 4 minutes, right? It is one mark question. Then they can ask, calculate the maximum volume of carbon dioxide that is produced. It is also for 1 mark, right? So it is 70 centimeter cube, and the rate of reactions as well. Now, one more thing, Bacho, we can even find out the average rate as well. We can find out the average rate as well. And what is the average rate? It is the total volume of gas that produced over total time, right? So examiner can ask also this way. So it is 70 over 4. So what is the answer? It is, I think, 17.5 centimeter cube per minute, right? So this is the average rate, the overall rate that is showing this graph, okay? So in all 4 minutes, if we take the average rate, so it is just like this. So you need to understand this one. बच्चों कि अगर वो आपसे rate पूछ रहा है किसी specific second का, so you need to find it in this way, the first 2, 3, and 4th rate that I showed you. Then अगर वो आपसे average rate पूछता है, then you need to show in this way. You need to take out the total volume and then total time, and then you need to divide both of them. So you will have what? Average rate. तो आपको क्वेश्चन को देखकर समझना है वो क्या पूछ रहा है, then you need to solve it. Okay, बच्चों?
Yes.
Now, we have a few more things that are very important, like effects. Effects are very important part of this chapter. Multiple times they ask about effects, right? They ask about factors that can affect the speed of reaction. So I'm just taking a side of this graph and then I'm showing you it later on, right? Then let's talk about factors. Factors that can affect, you can say that factor affecting speed of reaction. Right? So we have few factors that can affect the speed of the reaction, and they are what? The first one is what? Definitely the concentration. The concentration of reactants. The concentration of reactants, right, bacho? We know that, for example, over here in the graph, you can see that whatever the concentration, if I doubled it, right? If I double the concentration of reactants, definitely the reaction will be faster. Why, bacho? We know that reaction fast क्यों हो जाएगा? Because we have more particles of the reactant. जब हमारे पास reactant के particles ज़्यादा हो जाएंगे, so definitely there is more collision in the particles of the reactants. जब reaction का collision बढ़ जाएगा, then definitely we have more products and more rate of reaction, right? So you can write it in this way. For example, we have more particles, more particles of reactants, right? And then there are more collision between them, right? And then we have more speed, or you can say that speed of reaction, right? We have more speed of the reaction, right? So then the second thing that the very important thing about the papers, the past papers, is particle size. Particle size, or you can say that it is also in, you can say that it is surface area. Surface area, right? But so for example, if we have a block, or you can say that if I have a beaker, right? And in this beaker, I just place a iron block. I just placed a iron block, and we have water over here, right? So we know that iron get rust, right? When there is a water along with the oxygen. So you can see that the rusting start on the surface of iron, right? So definitely the molecules of water interact with the particles of iron that are on the surface. But the thing is, the inner molecule, or you can say that the inner atoms or the inner particles of iron are safe. They are not in the interaction with water, right? When they are not in the interaction, definitely they are not going to be react, right? बच्चों, अंदर वाले react नहीं कर रहे हैं, उसकी वजह क्या है? क्योंकि they are not in the interaction with water, वो पानी के molecules के साथ interact हो ही नहीं रहे हैं, ठीक है? But if we want to react them with water, तो हमें क्या करना चाहिए बच्चों? हमें करना चाहिए ये कि हम क्या करें, पानी का जो वॉल्यूम है उसको चाहे हम सेम रखें, कोई फर्क नहीं पड़ता, राइट? We just need to do what? We just need to crush them into pieces. When we crush them into pieces, definitely the surface area of iron will increase. When the surface area of iron increase, it is due to the number of greater particles of iron, right? So there is a more interaction of water molecules with iron. When there is more interaction, there is more speed of reaction or the rate of reaction. It is the same thing. It is the same thing that we are doing in our houses. What we are doing in our houses, you all know that we just take a glass of water, we just add sugar in that, right? For example, if I just adding sugar in that water glass, so we just going to stir that, right? आपने देखा होगा ना, आप सबने अपने घरों के अंदर जब हम चीनी को या नमक को या किसी भी चीज को पानी में मिक्स करते हैं, तो हम उसको चमचे से जो है शेक करते हैं, या हम उसको सर्कुलेट करते हैं, या हम उसको स्टीयरिंग करते हैं चमचे से, राइट? देखा है बच्चे आप लोगों ने?
जी।
वो क्या होता है, वो हम क्यों करते हैं? वो हम इसलिए करते हैं ना, क्योंकि जब हम शुगर के पार्टिकल्स को डालेंगे तो शुगर के पार्टिकल्स सारे के सारे नीचे सेटल डाउन हो जाएंगे, तो नीचे वाले जो पानी के मॉलिक्यूल होंगे वो शुगर के पार्टिकल्स से क्या कर रहे होंगे? इंटरेक्ट कर रहे होंगे, और वो डिसॉल्व हो रहा होगा आहिस्ता आहिस्ता। बट हमारी अम्मा क्या करती हैं, हमारी बहनें क्या करती हैं, वो उसको मिक्स करना शुरू कर देती हैं, तो उससे क्या होता है? शुगर के पार्टिकल्स नीचे नहीं बैठते, बल्कि वो ओवरऑल पानी के सारे वॉल्यूम के अंदर क्या हो रहे होते हैं? मूव कर रहे होते हैं। When they are going to interact with more water molecules, they are going to dissolve earlier, right? वो जल्दी से dissolve हो जाते हैं, क्योंकि ज्यादा पानी के molecules ज्यादा शुगर से interact हो रहे होते हैं, that is why they dissolve quicker, right? The same thing is about what? Particle size of iron over here and this. तो जब हम इसका particle size बढ़ा देंगे तो पानी के molecule से interaction बढ़ जाएगा, then there is a speed of reaction, you will see, right? Right बच्चों? So we can write over here, we can write over here increase, or you can write over here as well, increase the concentration of reactant, increase the rate of reaction, increase the speed of reaction or the rate of reaction, whatever you need to write, speed of reaction. The same thing over here, increase the number of particles, increase the number of particles of reactants, or you can say that increase the surface area will increase the rate of reaction, will increase the rate of reaction or the speed of reaction, whatever you want to call it, you can, right? And what is the reason? The reason is greater number of particles, greater number of particles, greater will be the collision, greater will be the collision, right? And when there is a greater collision, there is a greater speed, right, bacho? So you need to remember this. It will be asked in exam for 2 marks. Okay. Then the next thing, the very important factor is temperature, right, bacho? Temperature is a very important factor. And again, we all see the effect of temperature in our houses as well. For example, if you just going to add a few amount of sugar in the in the in the cup of tea, okay, and if you are going to add the same amount of sugar in the cold roux, right? So what you will see, that in cold roux, the dissolution of sugar will take time, but in the hot cup of tea, you will see that the same amount of sugar will dissolve earlier. Why? There is a difference of temperature in these two glasses, right? When you talk about roux, it is cool, okay, and we talk about a cup of tea, it is hot. So when you add the same amount of sugar in both of them, you will see that the sugar in tea will dissolve earlier. Okay, so let's have an example again. This is a cup of tea. Okay, this is tea. Definitely it is hot. And when you are going to add 1 teaspoon sugar into this, and for example, if you have 1 cup of roux and you are going to add, it is cold roux, it's a very Pakistani mushroom, and you are going to add 1 teaspoon also sugar into it. So you will see that it is quicker and is lesser. Why? The reason is temperature, right? The reason is temperature. So if you increase the temperature, definitely the speed of reaction or the rate of reaction will be increased. Rate of reaction will be increased, right? And why? What is the reason? What is the reason behind this, right? Increase the temperature, we all know that will increase the kinetic energy of the particle, will increase the kinetic energy of the particles, right? So the chances of collision increased. The chances of collision increase, so definitely the rate of reaction increase. Right, but you need to remember this pattern. It is very important. Increase the temperature will increase the kinetic energy of the particle, will increase the you can see that the chances of collision over there between the particles. So definitely it will increase the rate of reaction, right? You need to remember this pattern. Increase the temperature will increase the kinetic energy, will increase the chance of collision, will increase the rate of reaction, right, bacho? Yes, Hamza, is that clear? Asna, is that clear?
Clear.
Okay, one more time. For example, if I decrease the temperature, okay, for example, if I decrease the temperature, so what happened? We know that if you decrease the temperature, the kinetic energy of the particle decreases, then the collision chances will be decreases, then the rate of reaction will be decreases, right? Is that clear?
Yes.
You need to remember this. It will help you out to give you 2 marks in the exam, okay? Okay, Hamza, am I audible to you? Why are you not answering?
Yes, sir. You're audible.
Okay, thank you. Okay, so this is the effect of temperature. So you need to remember this as well. It is very important. And the last, but not the least, we have an effect of pressure. We have the effect of pressure, but pressure can only affect gases, right? Pressure can only affect gases, not everyone in the container, right? So why the pressure is only applicable on gases? Why not on liquids? Why not on gas solids? We know that solids are not compressible. We know that the particles are tightly packed to each other. We know that liquids are also not compressible because they have fixed volumes, right? They are not compressible because their particles are closely packed to each other, right? Although they are they are disorder in arrangement, but they are closely packed to each other. So when solid and liquid are not compressible, so definitely there is no use of pressure over there. Their particles are already near to each other, right? But if we talk about gases, so the particles of gases are far apart from each other, right? Are far apart from each other, right? So when we apply the pressure, the particles come closer, and there the chances of collision will be increased, right? So the pressure is only applicable for gases. You need to remember this, okay? So it is again the same thing that we need to remember. For example, if I have over there a beaker, in this beaker, for example, there is a reaction of sodium metal with chlorine gas. You know that chlorine gas, the molecules are far apart from each other, so they are reacting with sodium, but very rarely. They are reacting. In fact, they are reacting. Both are reactive, but very rarely because the particles are far apart from each other. So, for example, we just close the container. We start applying the pressure over there. So, in this way, the piston will be downwards, and it will cause particles to come closer. But again, the rate of reaction is not appropriate. So, what we do, we just apply more pressure. When we apply more pressure, the particles come closer more. When they come closer more, they start reacting more quicker, right? So in this case, they start reacting fast. Okay, so you can say that increase in pressure of the gaseous molecule, increase in pressure of gaseous molecules will increase the rate of reaction, will increase the rate of reaction. Right, Bacho? And what is the reason? What is the reason? Reason is what? Increase the pressure. Most of the time they ask this, now. Increase the pressure to cause molecule of gases to come closer. Molecules of gases to come closer. Chances of collision increase. Chances of collision increases, right? Hence the rate of reaction increases, or you can say that speed of reaction increases. Right, Bacho? Is that clear?
Yes.
And the only thing that can affect the rate of reaction but not the productivity is catalyst, right? Catalyst can speed up the reaction. We all know that. What is the purpose of catalyst? It can speed up the reaction. It can speed up the reaction, right? It can speed up the reaction, but how? Why catalyst can, you can say that why catalyst speed up the reaction? We know that by lowering the activation energy, by lowering the activation energy, right? There is no effect of catalyst on the product, but definitely it will speed up the reaction, right, Bacho?
Yes.
So you need to remember these particles or these effects. They are very, very, very important. And most of the time, or you can say that all the time, they ask these effects in the paper. So what is the effect of these things on the graph? So if you focus on the graph, so over here, if you use catalyst, so the graph will be a little steeper, right? It will be like this. Okay, so the reaction will complete in less time. It is completed in 3 minutes. You can see over there, right? If you increase the temperature, so this has become steeper, right? In this way. This is the effect of what? Temperature. This is the effect of what? Pressure for gases. This is the effect of what? This is the effect of catalyst. Or you can say that this is the effect of particle size as well. right? But the effect of concentration will be what? If definitely you are going to increase the concentration of any reactant, so definitely their reaction will increase. So the product is also increased. The reaction will be stiffer, definitely, but it will cause more product to form, right? It will cause more product to form. So there is a difference. You need to remember this, right? There's a difference of the productivity. The amount of gas will increase. Definitely, if you are increasing the reactants, the product is also going to be increased. So the amount of gaseous molecules that are liberating from there will be increased. So you need to remember this difference. If the graph is given in this way in MCQs, so you need to remember this. There is an effect of changing concentration, right? Not any other effect. And if you are changing any other effect like pressure, temperature, catalyst, and particle size, so it will give you the same amount of gas, but the reaction will be a little faster or stiffer in graph, right? Right, Bacho?
Yes.
Is that clear, Hamza?
Yes, sir.
Okay, so you need to remember these things. These are very important part of this chapter, right? You can take a snap of this. Definitely it is a difficult one to take. You can take this a snap. First, take this a snap. It's important one. Done? Done, Bacho?
Yes.
Okay, and these are very important factors in the paper. You will see that most of the time, if you have physical past papers with you, you can see that सबसे ज्यादा यही सवाल पूछते हैं, टेम्परेचर और प्रेशर का तो बहुत ज्यादा पूछते हैं. और देखो बच्चों, हमारे पास जो है ना रिवर्सिबल रिएक्शन भी हैं जिसमें ये फैक्टर्स मौजूद हैं, टेम्परेचर के, कंसंट्रेशन के, कैटलिस्ट के. रिवर्सिबल रिएक्शन भी अभी हम पढ़ेंगे, उसके अंदर भी यही इफेक्ट्स हैं और इसमें भी हैं. सो व्हाट इज द डिफरेंस बिटवीन रिवर्सिबल रिएक्शन एंड दिस? जब कभी भी वो आपसे रेट ऑफ रिएक्शन के बारे में पूछेंगे ना, वो पूछेंगे एक्सप्लेन इन टर्म्स ऑफ कोलिजन. ठीक है, तो आपने ये वाले बताने. ठीक है बच्चों? तस्वीर ले लिया आप लोगों ने?
Yes.
और ये भी ले लें आप पिक्चर, and then I'm giving you one example question and you need to answer that. Okay, let's take this first. Done?
Yes.
Okay, so here I have one question with you too. Okay, आपने मुझे इसका जवाब देना है. So for example मेरे पास ये एक ग्राफ है. मैं कुछ ग्राफ बनाने की कोशिश करता हूँ, आसान सा ग्राफ. ये ड्राइंग इतनी अच्छी नहीं है बट मैं कोशिश करता हूँ. कॉपी पे बहुत अच्छी है, बोर्ड पे बहुत अच्छी है, बट इस पे पता नहीं क्यों मुझे इतना गंदा फील आता है आईपैड पे. बट मैं कोशिश करता हूँ कि आपके लिए कोई अच्छी सी ड्राइंग बना सकूं. ओके बच्चों, सो दिस इज द क्वेश्चन. फॉर एग्जांपल ये ग्राफ आपके पास यहाँ ज्वाइन हो गया और एक ये ग्राफ आपके पास ज्वाइन हो गया. ये दो ग्राफ है हमारे पास जो मैंने यहाँ पर ज्वाइन कर दिए हैं आपके लिए. ठीक है, द क्वेश्चन इज this is graph A and this is graph B. Okay, so the question is, for example, 100 centimeter cube of 0.1 mole per decimeter cube HCl react with magnesium ribbon, right? And in the second one, it is A. No, it is 1, okay? And it is 200 centimeter cube of 0.1 mole per decimeter cube HCl react with the same amount of magnesium powder, right? बताइए कि जो आपके पास ग्राफ ए है वो कौन से एक्सपेरिमेंट का है और ग्राफ बी जो है वो कौन से एक्सपेरिमेंट का है। फर्स्ट ऑफ ऑल हमजा आप मुझे बताएं कि कौन सा ग्राफ कौन से एक्सपेरिमेंट का है। Yes, Hamza, can you please tell me?
सर जो नंबर 1 है वो बी वाले लाइन पे होगा
अच्छा, और
और
2 वाला है वो एक और।
2A।
ठीक है, so you are saying 2A and B1. Okay, it's Hamza's answer, right? So what is yours, Asna?
I think the same.
You think the same? Okay, very good, but I think you both are wrong. Okay, why? The reason is you can see over here the amount of HCl is same, right? So there is no effect of HCl over here, right? The only thing that can differ over here is magnesium ribbon and magnesium powder, right? Now you need to think about it, बच्चों। magnesium ribbon जो है it is just like this. It is a magnesium ribbon, right? And the magnesium powder is just like this. So the particle size and the number of particles are greater over here, right? So the reaction is faster over here. So it is stiffer, right? So this is the second one and this is the first one. Okay,
Yes.
got my point? What I am trying to teach you, बच्चों, समझ में आया?
Yes. More surface area.
Exactly, more surface area, then more particles, then more collagen, then more rate of reaction, right? These are in raw. Okay, yes, Hamza, got it?
Yes sir।
For example, if I just add one more thing over here, just like this, so which change can cause this? क्या चीज मैंने चेंज की होगी जिसकी वजह से ये हुआ होगा?
The concentration of any of the.
The concentration of HCl or magnesium, whatever, दोनों में से कोई भी बढ़ा सकते हैं ना, ठीक है? बट यू नीड टू रिमेंबर कॉन्सेंट्रेशन हमें किसकी बढ़ानी है? कॉन्सेंट्रेशन ऑफ लिमिटिंग रिएक्टेंट, ठीक है? We need to increase the concentration of limiting reactant. We don't know right now which one is limiting reactant, but you need to remember कि आप हमेशा किसकी बढ़ाओगे? You need to increase the concentration of limiting reactant. जो चीज कम होगी ना उसको बढ़ाने से रिएक्शन में फायदा होगा। फॉर एग्जाम्पल, अगर एक चीज ऑलरेडी कम है तो जो रिएक्शन होगा वो हमेशा यहीं खत्म होगा ना, तो हमें लिमिटिंग रिएक्टेंट को बढ़ाना होगा, तब जाके स्पीड ऑफ रिएक्शन पे या प्रोडक्टिविटी पे फर्क आएगा, ठीक है? तो चीज एक्सेस में है उसको बढ़ाने से कोई फायदा नहीं, ठीक है? इज दैट क्लियर बच्चों?
Yes.
Okay, so this is today from my side, and we will inshallah proceed towards past papers from tomorrow. And I think that is all about rate of reaction that I can teach you about rate of reaction from book and from past papers and from your syllabus. And you need to learn all of these effects before tomorrow. क्योंकि कल हम past papers करेंगे, तो अगर आपको ये सारे कॉन्सेप्ट याद नहीं होंगे, अगर ये सारे फैक्ट्स याद नहीं होंगे, तो फिर हमारे लिए मुश्किल होगी, ठीक है? सो ऑल ऑफ यू डेफिनेटली जस्ट हैव टू राइट नाउ। सेजर के पेपर्स चल रहे हैं, वो नहीं आ रहे हैं, और कनाडा में कोई इंटरनेट का इशू चल रहा है, तो हमारे साथ अब्दुल्ला और ज़ैफा भी नहीं है, बट आई कैन शेयर दीज रिकॉर्डिंग्स विद ऑल ऑफ देम। सो आप लोगों ने बच्चों रिवाइज करना है, ठीक है? रिवाइज करने के बाद आपने इन सारी चीजों को याद रखना है। याद रखने के बाद इंशाल्लाह हम कल पास पेपर्स करेंगे, तो कल पास पेपर्स में हमें इन सारी चीजों को यूटिलाइज करना है, और मैं आप लोगों से सवाल पूछूंगा तो आप लोगों ने जवाब देना है, ठीक है बच्चों? Got it, Asna
Okay.
and Hamza?
Yes, sir.
Okay, thank you so much for your time and attention. I am sending you the recording in few minutes, inshallah. You need to review that. You need to learn the concepts. You need to learn the factors. You need to use all of them in tomorrow's class just to check yourself. Where are you standing in this chapter? Okay. Take care of yourself. Stay safe. Stay blessed. Allah Hafiz.
Allah Hafiz.
Allah Hafiz. Hamza, kindly send me the recording. Okay.
Okay, sir.
Okay. Take care of yourself. Allah Hafiz.
Okay, Allah Hafiz, sir.